Emerald, can you reach the switch for us there? Just that one. Yeah, thank you. And so here we go. So first of all, we're just going to talk about lines at first. You remember IPR, you would graph linear relations, right? And then you went into a system, right? Remember, more than one line at the same time. And if you're kind of having nightmares, like I didn't like that part, right? We're not going to solve a system with those methods you were taught. Like remember elimination, substitution, all of that. You don't have to worry about that. We use our graphing calculator for that. So we can have like ugly equations that look really scary, no big deal, because we're just inputting it in here, right? So, and then we'll graph it and actually find the point of intersection using our calculators, but you still need to know how to rewrite equations and how to find the intercepts. Okay, so that's the kind of what I'm going to focus on. So here we go. There are 4 types of slopes. And you should recall that slope is always rise over run. Okay, like how much you're changing in your vertical for every unit of run. Okay, and so in this case, is there somebody that's still owing me a ruler? If you have one of my rulers, if you can give it back, I'd appreciate that. But anyway, so I'm gonna split this into 4 columns here. So don't make the lines too dark, just kind of like if you don't have a ruler, it'll be okay, but your notes just won't be as good. So if you can get a ruler actually especially for this unit, it doesn't have to be anything extravagant, just, 15 centimeter will do. So we have 4 columns here, and try to space them out equally, right? So you have an undefined, you have a positive slope, you have a negative, and you have a 0. A lot of students mix up undefined with 0, right? So I'll try to make sure you don't get that wrong. Okay, so undefined is when, right? Undefined is when you have a rise, but you have no run. Okay, and that is undefined, obviously. It's not 0. Okay, maybe this will help you remember. If you take, 28, any number, and you divide it by 0, it's going to say error. Can't do it. Divide by 0. Something is wrong. So by the way, if you get an error like this, 1 is it's going to quit, and if you press 2, it's going to take you to the thing that it doesn't like. Go to. So if you hit enter, it's right now it's just right next to the 0 there. It's not liking it. So it's asking for something else, right? So if you have a rise but no run, you have an undefined slope, and here is my grid. So I'm just going to make a small X and Y axis here, nothing fancy. Okay. I'm going to be very picky with arrowheads on your axes, right? X and Y if it's not something else. And in this particular case, let's just, for instance, use this here. We're going to make a line, a vertical line, right? That goes through, let's say this is -2. And we may have to extend these columns a little bit, okay? But the equation of this line would be what? Anybody remember? The equation of a vertical line always starts with, is it y equals or x equals? That is the question. It's not y equals. It's x equals, right? It's a 50-50. And I think that's why a lot of students get this wrong. But yeah, it's just x equals 2, -2. That's the equation of that particular line. And if you think about it, look at this line. No matter where you are on that line, what's x always equal to? -2, right? It doesn't matter where you go. X is always equal to -2. So there's your, maybe that will help you. And in general, a vertical line is x is equal a number. Okay. And it's always a vertical line. I hope you can see that, but there it is. It's always a vertical. How about I do this for now? I'm just going to zoom into the positive and the undefined there. There you go. So positive, yeah, your slope is just going to be something, something. It could be a decimal fraction, you name it, but it's going to be positive. Okay? So then when you have your little grid, okay? Which way is it? What's going to happen if you go from left to right? That's how you read a book or a sentence. You're left to right. What's going to happen from left to right? Is it going to go up or down? It's going to go up. Yeah. So I'm going to go like this. Make my line going up. Sometimes they say that it increases from left to right. And I will extend this division here. In fact, I'll do the same for all of them. And then I don't have to worry about it. And so there are 2 points in particular we're interested in. What's this called? It's point of intersection. In particular, something intercept. It's on the y-axis, so it's the y-intercept. And this is the x-intercept. I know, for some of you, it's been a year, right, since you took math. So it's kind of like, right? I don't remember. Something. It's called something, of course. Equation. I will just give you the general in this case. It would be y is equal to mx plus b. You recall that? That's like, this is the slope intercept form, and that's the one we're going to focus on. So I'm just going to give you that. A couple of things here. It will be a diagonal line. It's always diagonal. If you have both variables in the equation, it is going to be a diagonal line. It's not horizontal, it's not vertical, diagonal. Okay. Couple more things here. Maybe let's just do it on this one. We have quadrants. So this is quadrant 1, quadrant 2. I use Roman numerals. I honestly don't care if you do it either way. Quadrant 4, right? So you start here and then you go 1, 2, 3, 4, right? So just in case I ask you that on an AC or something, you know what's going on. Okay. And then we have our negative slope, right? And we'll make another quick grid here. You can use a ruler or just do it by hand, that's fine. So this one in particular is going to go down from left to right. Equation is the same. Y is equal to mx plus b. It's still a diagonal line. And one more thing. I don't know if you left as much space as I did here in between. If you don't, just put it under. But you would say that it increases from left to right. Sorry about that. But it says it increases from left to right. I just put that down there. Let me just focus one more time. Hold on. When I zoom in like that, it doesn't always. There. It increases from left to right, and this one decreases left to right. How about we just do that? So if the line goes, if you look at the line from left to right and it's going down, it's going to have a negative slope regardless of what you're doing. It's going to be negative. That's your expectation. Okay, and now the last one is the zero slope. Let me just move over a little bit. There you go. So our zero slope, obviously slope is, this is different. This is where you don't have a rise, right? But you may have a run, right? So that is actually a zero slope. Like you can actually go 0 divided by 1,000,000 is still 0, right? Like you can have that. And if you forget, just try it on your calculator. Right? Which one is which, right? Y and X. And this is a horizontal, so let's go up here. Let's make this point right here along the y-axis. Let's make that 3 positive. Equation is going to be y equals 3. And I will say it's a horizontal line. It's a horizontal line, and in general, it goes y is equal to a number. Sometimes it's not apparent that it's a horizontal line until you clean it up. Bring all your variables over to one side, and then things will cancel out. It's like, oh, what happened to x? X is gone. Oh, so it's just y? Okay, then it's a horizontal line. No big deal. So make sure well, you'll see. I'll give you quite a few examples there. And that's it for this. So this is one big box. Just one big box, just reviewing, right? You have it all one there. It's a snapshot of what you've learned last year or last semester. Some of you, it's been last semester, right? So it's fresh. And this is one, if you had me before, you know this one. I'm just going to give you this on the side here. So any space you find, Mr. Slope, right? Some of you are already saying, yeah, I remember that, right? So if slope goes up, it's positive. If it goes down, it's negative. Right? A vertical line has an undefined slope. Right? A horizontal line has 0 slope. So that's Mr. Slope right there. Right? Positive slope goes up, negative slope goes down. Vertical has an undefined slope. Horizontal line has a 0 slope. Okay, that's a quick, just you'll remember, hopefully. Okay, let's keep going. There we go. And I will say this. graphing linear equations by hand. Okay. Graphing linear equations by hand. So this is how I do it. So if you, for example, are given, let's say you get a 3x plus 2y is equal to 6. I'm not going to ask you what form it's in, right? General, standard, slope, intercept, point slope. Remember those? You're not going to have to really worry about that. You just treat them all kind of the same way. So method 1, find intercepts. That's going to be my first method. Find the intercepts, x-intercept, y-intercept. And this is how I do it. I just say the x-intercept is going to be right here. And I'm going to make a t-chart and do the y-intercept right next to it. So I have them all in one spot. Okay. I'll zoom into that one there, right there. Because all the action is going to happen right there for now. I'll do more of the zooming in, okay? I'm going to get better at it. I'll try. I can't always do it. But x-intercept, you just got to remember, if I'm trying to find the x-intercept, then y is equal to 0. I won't do this every time. And if you're trying to find the y-intercept, x is equal to 0. So it's almost like the opposite. If I want the x-intercept, I make y 0, and so forth. And so we take the top here. After a while, I'm going to be quick with this, and you don't have to show me every single step. But we're going to go 3x plus 2 times 0 is equal to 6, right? I'm substituting 0 and for y there. And that basically cancels this out. That's gone. So it's really 3x is equal to 6. And then you divide both sides by 3. Do you remember that, right? When something's multiplying x, you got to divide both sides by what's in front. If it's negative, pay close attention. If there had been a negative 3, we would divide both sides by negative 3. And you'll see how that goes, right? So this is 2. So I just found a point. I found a point that where 2, right? 2, 0, that's the point I found, right? When y is equal to 0, x is equal to 2. Okay? So make sure you have that down. I always like you to state it like this, right? As a point, as a coordinate, right? And then we go over to this side, we do the same thing, but now x is equal to 0. So it's 3 times 0 plus 2y is equal to 6. We all know that 3 times 0 is 0. And I pick these numbers on purpose. It won't always be nice, round numbers. I prefer, well, you'll see. Divided by 2, divided by 2. Y is equal to 3. So you found the point that when x is equal to 0, y is equal to 3. It's very important that you don't mix them up. Students mix them up. They put 3, 0 down here because there's a 0 somewhere. It's a big difference, right, where that point will show up. And then, so this is method 1. Right next to this, we'll do method 2. Rewrite equation. And, oh, you can't see that, can you? Camera, okay. Method 2 is rewrite equation. And when I talk rewrite, I always mean slope intercept. Okay? Make it look like this. And that's what I mean by that. So I'm going to start with 3x plus 2y is equal to 6. And let the journey begin, right? Your teacher may have used a method where you add or subtract the same thing to both sides, right, to move stuff. I just say when something crosses the equal sign, it changes its sign. That's what I do. So watch how this goes. This 3x, I want that over on this side. So I'm going to go 2y is equal to negative 3x. So watch this, right? The 3x, that whole term, is crossing over to the other side, and you immediately need to change the sign of it. And the 6 is already on the right side, so I just tack that on like this. Right? Yeah. Order doesn't matter. Like you could have gone 6 minus 3x, but convention has it that we like to have the x in front and the constant behind it. Yeah. So now the next step is to divide everything by 2. How about I use blue here? Okay, divide this by 2 and divide this by 2 because our ultimate goal is to have y completely isolated on its own alone, right? So that cancels out. And then this is negative 3 divided by 2 x. That's what we tend to do. And I don't, this one I leave as a fraction no matter what. I leave this because we type that into our calculator later on and it can handle fractions. But the 2 also affects this. That's the biggest mistake I see. I see a lot of this, right? It's like, nope, the 2 affects this, and the 2 affects the 6 as well. So that is actually 3. And I don't know if you remember that B is really the y-intercept of, do you remember that? That constant in the back is the y-intercept, which we know is 3, right? We've already done the work. This is just to confirm this is the y-intercept, right? And that is our slope. Okay, make sure you have that. And maybe it's good because this helps to confirm to you that you're doing things right. Okay, if that is a 6, if you had a 6 here and a 3 there, alert, right? Something is wrong. I did something wrong. Go back, right? And now we will graph it. So you're gonna do so much graphing with me that by the time you get to grade 12, you'll do it with your eyes closed, right? You'll be like 10, 10, 10, scale, label, all of that. You'll ace it next year, okay? We're good. Now we're gonna graph it. Unfortunately I ran out of room, so I will just grab another piece of loose leaf here so that I can have them both. So this here, I can use a small scale, no big deal, right? I need to accommodate 2 in terms of my x and 3 in terms of my y. So let's go ahead and just make a grid like this. And quite often on a test, I provide you a grid, but I also, for ACs and stuff, you have to do it by hand. First thing you do is arrowheads everywhere, and then X and Y. And here's the kicker. You need to be consistent when you pick your scale. I don't care if you go up by 2, by 3, by 5, but you can't skip. You can't say 2, 4, 10. It doesn't work that way, right? You got to be consistent throughout. You can have a different scale for the X, and you can then have a different scale for the Y. I'm fine with that. You can go up by hundreds in your Y and by tens in your X. That's fine. So here we go. I'm just going to go 1, 2, 3, 4, 5. You know what? For me, I just try to space them out as good as I can, equal spaces, and then you do the same thing to the other side. 1, 2, 3, 4, 5. You're telling me that you're using a scale of 1. And I'm going to use the lines themselves, right, of my loose leaf to help me here. And unfortunately, this doesn't get me to 5, so I'm just going to do it like that. So you don't have to label every single tick. You just do every once in a while. That is enough for me. If you look, you know everything is 1. Every box or every tick is worth 1. So what are my intercepts again? Let's go here. 2, 0. That's the first one I'm going to find on here. So always start at the origin. 1, 2, right? 2 zeros right there. And then 0, 3 is my point on the y-axis. So I'm going to go here. 1, 2, 3. You don't need to label them. Just make a dot because your scale is telling me what's happening. And you draw your line. Please don't just do this, right? That's a segment. A line keeps going. You can feel free to extend quite a ways each way. Okay? No problem. Arrowheads on the ends. And last but not least, you need to write your equation down, which is 3x plus 2y is equal to 6, or the rewritten one. If you want to write this one here, just look up for 1 second. If you want to write that, that's fine, right? Okay, so we have that. We have our labels. So watch for label x and y. Okay. Choose scale. Right. Arrowheads on axes and line. Label line as well. In other words, the equation, right? So label x and y. For now, everything is just x and y, x and y. Later on, it will be time and height, distance and height, money and tickets sold, right? So it will change. So just be aware of that. How else could we have graphed this? I'm going to have to start from scratch, okay? So I apologize because this one example, I want to make sure. So this particular one was method 1 using intercepts, okay? And I will make an arrow, right, going to the intercepts. Remember where they told you in IPR you have to find 3 points to graph a line? Remember that? That's not really true. You only need 2 lines. For a parabola, which we're going to do next, a curve, yes, there you need 3. So they were preparing you for that. Okay, we were. Okay, so I'm going to zoom out a bit. And right under, so this is method 1. Method 2. Using y is equal to mx plus b. I will tell you the steps here. It says using y equals mx plus b. Start with y-intercept which is B, right? Then use slope, right? Rise over run to find additional points. I have a bias. I like to use the first method more because it's more fail safe, like fewer mistakes are made using that. So I'm going to do the same thing again. Here we go. I'm going to leave myself a little bit more space above because I'm going to start there. This is the Y, this is the X. I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So again, you don't need to label every single one. Here and there is fine, but you're clearly indicating what your slope is. I'm going to use a different color. First of all, I'm going to write down y is equal to negative 3 over 2x. Where's my paper? Plus 3. So from here, I know that 0, 3 is the y-intercept. And from here, I know that my slope is negative 3 over 2. Let's just put it this way. You're expecting the line, because of that negative, which way is your line going to go from left to right? You know it's going to drop, right? Because of that, you know it's going to drop. And I always make the negative go to the top. So if you have a negative in the negative 2, just bring it up to the top. So let's start here, 0, 3. And we're going to drop 3, right? The negative, if I make that apply to the 3, I'm going to drop 3. So 1, 2, 3. And how many am I going to run? 2. Which way? Always to the right, because I make the negative go up, and it will just affect this. So 2 goes 1 and 2. So that's my second point right there, which right now happens to be the exact same one as my x and y intercept. It won't always be. So, right, this is, you drop 3, you run 2. And there is my line now. And I'm going to label this one using this equation. I don't really care which one you use. This is amazing. It's going to blow your mind. Watch this. You could continue. 1, 2, 3. 1, 2. Look at that. Right? So technically, if your slope is right, you should be able to do that over and over and land on the line every single time. Okay? You're not so convinced, right? What's so amazing about that? That's okay. We don't all share the same passion, right? So there's that. I'm leaving it on there a little bit before I move on. I think I didn't put method number 1 on the first one, did I? So I'm going to go up and just go method 1. Just to make sure that we have it all. And this is just an aside. Maybe it will help you. Must have. Right? Here. Special cases. And that's x is equal to a number is a vertical line. Y is equal to a number is a horizontal line. So for example, if you have 2x minus y is equal to 3x minus y. Let's keep it simple. And you're like, both variables, diagonal line, right? Not so fast, okay? Rewrite first, okay? So what we're going to do is bring everything over to one side, right? So I'm going to go 2x, and this 3x is over here. What happens to the 3x when it comes over to this side? It changes its sign, right? Minus 3x. And the negative y is already there, so I'm just going to keep it there. And what happens to this y when it comes over? Yeah, switches signs, so it'll be positive. And what is left on the other side? If I bring this over and that over, nothing, right? 0. In this case, it's 0. So you go, this cancels out with this, because negative y plus y is 0. 2x minus 3x minus x, right, is equal to 0. What's going on here? I'm just going to go ahead and divide this by negative 1 and divide this by negative 1 because I want this positive, right? What's 0 divided by negative 1? It's negative 0, of course. I'm just kidding. It's 0. Yeah, it's 0. There you go. So is this a point? This is an equation. Equation of a vertical line. Okay, you did not find the x-intercept. It happens to be as well, but this is actually the equation of a vertical line. And I'm just gonna cheat a little bit and just use this little section here to graph it. And you know what? We're gonna keep the labeling at a very minimum here. Where is the line gonna go on? Wait a minute, it's x equal to 0. Isn't that right on the y-axis? You bet. It's going to be right on the y-axis. So it's the line x is equal to 0. So you go x is equal to 0. That's the equation of that line. So if you're not sure, bring everything over to one side and see if things cancel out. If they do cancel out, you have yourself a special case. example. Let's go a little scarier here. Let's use fractions, everybody's favorite. Can I say, I don't know what your teacher said last year, but when I have a fraction in front of a variable, I just multiply everything by that denominator. So I will multiply this side by 2, and I multiply this side by 2 as well. So 2 times half, right? This will just cancel. And then 2 times negative, sorry, not equal yet. And then 2 times negative 2 is negative 4. Negative 5 times 2 is negative 10. And you can already tell that there's no x variable, right? So you're expecting a special case here. I'm going to keep the negative 10 here. The 4 comes over adding. And so y is equal to negative 6. Okay. This is the equation of a horizontal line. You didn't find the intercept or anything like that. All you did is you rearranged it until you get to this point and you're like, oh, wait a minute, this is just a horizontal line. And I need a bit of room here, so watch what I'm going to do here. I'm just going to do the x-axis here and then just focus more on the negatives, because I know what's happening here, right? So it's x and y. So this is 1, 2, 3, 4, 5, 6. So this is negative 5 right about there. And there's my, it's supposed to go right through negative 6 there. Y is equal to negative 6. Okay. And I'm going to let you try a few. See if you remember that. So here you go. For each of the following, determine the intercepts double I, rewrite into y is equal to mx plus b, and triple I graph. Use method of your choice. I would just use my intercepts that I found, but maybe double check using your slope. So here we go. 4x minus 2y is equal to 18. 6x minus 5y minus 25 is equal to 0. What's going on there? 3x plus 2y is equal to 12. 4x plus 7y is equal to negative 7. E 2x is equal to x plus 5. F 1/3 y minus 4 is equal to negative 5. There are some special cases mixed in there. What I will do for today is I'll pass around a book with some grids on it. So you can just tear a piece off. It's like a little pad. So just take off one of those sheets that has a bunch of grids on them. So you can do the graphs on there to speed things up a little bit. So we actually have over 20 minutes, right? 25 minutes. So get to work, get started on this because we're going to need this for everything we do in this unit. The skill right here is very important, okay? I just want to clarify the homework after you've done this. If you look at this booklet right here, which is the skinnier one of the two, page 3, there are a bunch of equations there. I just want you to do 1 to 16. Actually, 1 to 15 it looks like. But don't do all of them. I'll post a key. I just want you to practice rewriting, bringing stuff over, making it look like y equals mx plus b, because that's very, very important. Your signs are going to make, if you don't get the sign change and all that, you need to practice that. If you don't know what happens when you divide everything by negative, you need to make sure you practice that, okay? I'll just put the key up there for the first couple. Positive or negative? Positive. It's a negative.